morning, one and all. Yes, sir. Yes. Good morning, one and all. Sorry for the delay in starting the session today because of a lot of technical issues. The session got delayed by nearly half an hour. So we apologize for that. I'm very happy that Dr. Rajendra Hegadi, Associate Professor, IIIT, Dharwad, has accepted our invitation and accepted to be a part of this program to share his knowledge on blockchain technology. So talking about Dr. Rajendra Hegadi, he's an Associate Professor in the Department of Computer Science and Engineering, Indian Institute of Information Technology, Dharwad. Has more than 25 years of teaching experience at various capacities. He also worked as a system analyst in a software organization and has undertaken many project consultancy. He's a senior member of IEEE, member of CRSI, CSI, and ISTE. He's a member of IEEE Standard Association P2145 Standards, Development Working Group Standard for Framework and Definitions for Blockchain Governance. Currently has a consultancy project on high-level software architecture development to integrate healthcare applications of Health and Family Welfare Department, Government of Karnataka. His area of interest are computer networking, information-centric network, cryptography, and network security and image processing. He has published several research papers in reputed journals and a book chapter. He holds MSc in Physics, MTech in Computer Science from NITK Surathkal, and PhD in Computer Science. He has earned Gates Scholarship for his MTech course. I heartily welcome you, sir. Over to you, sir. You are now the presenter. You can start sharing the screen, sir. You have to unmute yourself.
Yeah. Fine. Is it audible now?
Yeah, you're audible, sir, but the screen is not.
Yeah, I'll share it.
I'll screen, sir.
Yeah, sure. Yeah, I'll share the screen. First of all, I apologize for the delay. In fact, I am not at my place at Dharwad. I am because of some family function. I keep on moving, but anyway, I really sorry for the delay which has happened due to me and because of some network issues and some computer issues. So, madam, will I have the time of 1.5 hours, or I had to reduce this?
So you can take. So the next session starts at 12.
Which I sent to you.
Should I share the PPT, sir?
Yeah. Please.
Okay.
Please share the screen, madam. Yeah.
You can start, sir.
Yes, madam. I can see now. Can we start now? It's almost 37 minutes late. Okay, fine. First of all, I thank the organizers taking great initiation to organize this faculty development program, specifically on blockchain. And I thank all the team members for inviting me, giving me an opportunity to speak on Ethereum blockchain. Please go to the next slide, ma'am. So, the continuation, I assume that all the participants have the knowledge of what is the blockchain and what is a block, how the blocks are changed, what is the Merkle root, and some background idea about hashing algorithms, specifically SHA 256, which is being used in blockchain, and digital signature, public key crypto system, and mining, idea about mining, incentive mechanism in mining, and mining rewards, etc. So I assume that you have a knowledge because already 3 sessions are over and you have put up some information about that. So today's discussion will be on Ethereum blockchain. We will learn about Ethereum history, types of Ethereum, Ethereum ecosystem, specifically components of the Ethereum, and we will conclude it. Please go to next slide. Please go to next slide, madam. Yeah. So before going to Ethereum, let us discuss Bitcoin and Ethereum. What makes the difference between these two? Why I have taken Bitcoin is all of us, one or the other way, we have come to know that there is a cryptocurrency and which is doing wonderfully well and a well thought idea, well implemented idea, and it is doing extremely well. And some of us, some participants might have invested in Bitcoin and making good amount of money. The cost of each Bitcoin is now $18,000. That's a huge amount. It has started from zero. To be remembered, when Satoshi Nakamoto started Bitcoin, it started with a $0. Now it has reached to one Bitcoin value is $18,000 plus. This morning I saw it. So what makes the Ethereum and Bitcoin? To recollect it, Bitcoin, a cryptocurrency, is the basis that came into existence. That's how the blockchain generated, blockchain idea generated. Look at this. Bitcoin is what? Nothing more than the digital currency. It's a peer-to-peer electronic cash system where you can transfer your electronic cash. That is Bitcoin. Whereas Ethereum is a ledger technology built on new programs. This is much more robust. You can build distributed applications on the top of blockchain and you can deploy them. Right? You can write smart contracts. Bitcoin is less robust. Not much is there. You know, you can only transfer Bitcoins from one account to another account. You can't write much more robust smart programs. Cryptocurrency for the Bitcoin is Bitcoin, and for the Ethereum it is Ether. Bitcoin you can write simple applications, specifically using scripting languages, whereas Ethereum is a computing frame where you can build more complex applications. You can write smart contracts. You can build distributed applications, right? So Bitcoin has some more the privacy, anonymity. There's a huge issue with that. Like there are some issues. Anybody can get into Bitcoin. I can get in. Anyone in the world can get into the Bitcoin. They can download an entire ledger and verify it. But however, the entities are maintained anonymity, where you cannot know who exactly holds a particular account. Ethereum is more, it is open for innovation. You have everything. It is like also, it is much more where you can write distributed applications, write smart contracts. What are these things we will see in a later slide. Please, next slide. Yes. So Ethereum fundamentals, if we go to the Ethereum fundamentals, conceptualization was brought by Vitalik in the year 2013, and this is suitable for the platform to develop smart contracts for the blockchain and distributed applications. In contrast to the Bitcoin, where we can use a scripting language, it is limited in nature, allows only necessary operations, very restricted necessary operations. Whereas blockchain, Ethereum blockchain is more robust, where you can use Turing machine language, Turing complete programming language to write the script, run the script. It has a virtual machine where you can deploy your code and run the code, right? So that's what makes it robust. So there are different versions. If you look at the versions which are drastically, different, the reason for that is Ethereum allows to have innovations where you can build in and bring in lot of innovation and make the changes. That's how Ethereum has evolved over the time. So in Olympic came in the year 2015. In the same year, Frontier came. Then we have Homestead, and by that time, the Ethereum is now moving from proof of work to proof of stake. The two different consensus protocols. The Metropolis and Serenity are the two latest versions of Ethereum. Next, please, madam. Next slide. Yes. So Ethereum, if you look at it is a transaction-based state machine. We all of us know what exactly a state machine. See, Ethereum virtual machine acts as a state machine, which changes its state whenever transactions are executed. So transactions have their own lifetime. Transactions submitted by accounts, then it is verified, then it is validated. Once it is validated, then it is taken into the blocks. Miners mine the block and put that particular transaction into the block. And once it is accepted, it will be a part of Ethereum blockchain. So all these transactions, the state machine, virtual machine changes its states when the transactions are executed. So transactions are executed incrementally to reach it to the final state. So the final state is considered to be absolutely undisputed version of the state because it is immutable. Once it is accepted, it is into the block and it will be there forever. You cannot change it. In case you feel like needs to be changed, only thing you can create a new block which is connected with the current block. What are the changes have to be made, but you cannot change the block which is already accepted into Ethereum blockchain. So world state is stored into the Ethereum. Means world state in the sense every node accepts the entire blockchain as their ledger, and you can also connect and download anytime within okay. So Ethereum is a peer-to-peer network where nodes maintain blockchain based on the consensus. So anybody can also get into the Ethereum right? There are different Ethereums that we will see. The most generic Ethereum, anyone can join there. Anyone can download the entire ledger from the Genesis block to the current block. Yes, next slide, madam. Yes, sir. So there are three types of Ethereum networks: mainnet, testnet, and private net. So, mainnet is what? The currently live network of Ethereum, which has moved from, the current version is Byzantine Metropolis Ethereum, which has a chain ID. See, every Ethereum has its own chain ID. So chain ID is one, in the sense this is the main the Ethereum blockchain. Next slide. We will go to the testnet. Next slide, please. Yeah, testnet. This is what the one of the versions, one of the type of the Ethereum blockchain, which most of us are very much interested. The very reason for this is like we have this testnet platform, blockchain platform, which is also called as Propston, widely used test network for Ethereum blockchain. So this particular blockchain, we can create smart contracts, we can execute them, we can do the experimentation, we can develop distributed applications, we can deploy these applications on this testnet. So this testnet is basically open for everybody. You want to do research, you can come up with a new consensus mechanism which is different from all the existing consensus mechanisms. So all these possibilities are there over the Ethereum testnet, which is open for all. So this allows experimentation and research. The main testnet is Robusten. Others are Coven and Rinkebi. In fact, these are all part of the Robusten. Robusten contains all the properties of Coven and Rinkebi. So you can say it is a superset of Coven and Rinkebi, right? So if at all you want to do any kind of research, any kind of experimentation, you want to develop your own private blockchain, you can use the Ethereum testnet to do that and write the codes and execute them. Next slide, please. Yes. So the third type is private net. Private net is, the private net. Of course, it is private means private. So you can have your own. Say, for example, a bank, it wants to put everything over the blockchain network. It can create its own private network where you can, every entity of the bank, every branch of the bank can be a node in the system. So that can be a part of it. You can create it. So there are network IDs. As I told you, Ethereum mainnet is the main Ethereum, where Ethereum cryptocurrency is used to exchange the things. And there are modern Raphuston. They have their own network IDs. So one is 42. Ethereum Classic mainset is 61. Next, madam. Next slide. So Ethereum ecosystem components. Now we are coming to the core discussion on this topic, Ethereum. So main elements are crypto keys and wallet addresses. So wallet means I can hold Ethereum wallet where I can store Ethereum Ether, right? Cryptocurrency. And for that, crypto keys are assigned to that wallet. Ethereum accounts. There are the different types of accounts. Transactions and messages. Any Ethereum account can submit the transaction and they can exchange the messages. A particular Ethereum account. It's not all Ethereum accounts. Then you have cryptocurrency, which is the Ether there. We'll discuss all these points. Then Ether virtual machine. That's what the main important the platform of Ethereum. So if this EVM exists everywhere in the network, all nodes will have this Ethereum virtual machine running for their system, and that's where the smart contracts are deployed. Distributed applications can interact with the Ethereum virtual machine for the exchange of information and exchange of the data. And smart contracts. So what are these smart contracts? What are the roles of smart contracts? Are they really smart? That we will look at in today's discussion. Please next slide, madam. Yes. If I am going too much fast, you can ask me to slow down. If you have a doubt, you can clarify, right? So first one is a crypto keys and wallet addresses. See, mainly used for the ownership and transfer of Ether. Crypto keys and wallet. Say, I want to own a particular set of Ether, certain amount of Ether. Then I need to create a wallet. Then I need to pay for that to have buy these Ethers. Then Ethers will be there into my address, my wallet. So my wallet has an address. So this address is one of the key in the key pair, that is public key, right? All of you have studied the public key crypto system. We will have two pair of keys. One of the key is made public, another key which is private key, which I will be knowing. So these keys are generated randomly. Public key is generated randomly using the check 256 K1 as the random key generator, the private key, which is of 256 bits, right? This is created by using the hashing code algorithm, check P 256 K1. Then public key is derived from the private key using electrical curve digital signature algorithm. So I assume that all of you know that electrical curve, digital signature, all those things. So address is what? Address, how do I know that this is a particular wallet? So when I want to transfer the Ether from one wallet to another wallet, I have to use the address. So this address is nothing but 156 bits of KCAT hashing of public key. You take a public key, which is the 256 bits, right? Get the hash code of it, then 150, the rightmost 156 bits will be the address of the particular wallet. Next slide, madam. Yes. The second one is accounts. Accounts, like there are two accounts. Accounts are the building block of Ethereum blockchain with Ether balance. So every account will have the Ether balance. Account can send transactions on the Ethereum. Accounts can be user controlled or deployed as a smart contract. So there are two types of accounts: externally owned account and contract account, right? So externally owned account controlled by humans using the private keys, and the contract accounts are the smart contracts deployed on the network controlled by the code. So the smart contract controlled contains a code which is executable code over the is a byte code on the virtual machine. So both type of accounts can hold, receive the send Ether and tokens. Both type of accounts can interact with a deployed smart contract. Next slide, madam. Yes. So externally owned and contract accounts. Let us look at the difference. Externally owned account, anybody wants to create it, you can create it. No cost is involved. It is free of cost. Contract accounts, yeah, that's how I am trying these two externally owned account and contract account in the slide, right? Contract accounts are, they require the cost. because using contract account, you can write smart code, you can deploy them on the blockchain. So when you write a code and deploy over the virtual machine, it uses a computing power as well as memory resource. So that's the reason it costs. So to create a contract account, it is going to cost you. Whereas externally owned account doesn't cost anything, because using the externally owned account, you cannot create the smart contract. You can only exchange the ether. Whereas external owned account can initiate transactions. They can initiate transactions. But contract accounts can only send a transaction in response to receiving transaction. So contract accounts receive transactions from externally owned account. So they are, the transactions are sent to them. So they can respond to these transactions after receiving the transaction. Externally owned account, no code is associated. You cannot have any code. You can only transact, do the transactions. You can say that, yes, I want to transact, I want to send certain amount of ether to this particular address. So that will be a transaction which will be submitted. Whereas transactions are, from the transaction between externally owned account to externally owned account by only ether. You can only send ether in the thing. Transactions from an external account to a contract account can trigger a code. So basically, contract accounts will lead to the triggering of the code on the virtual machine. This can trigger many actions like transfer of token, creating of account, exchange of messages, everything, right? All these things are possible with a contract account. So contract accounts are more more active on the Ethereum blockchain platform. So because of that, they consume lot of there's a certain amount of Ethereum virtual machine memory as well as the computing power. So because of that, it is going to cost for the contract account. So most of the time, these nodes, which are full nodes, we call them, will be contract accounts because they run on it. They also can create blocks and they can earn the reward, which can be allocated for the creating block for the miners. Next slide, madam. Now, every Ethereum account have 4 fields, right? Both of them, whether it is contract account or externally owned account, which are 4: counter, balance, code hash, and storage root, right? Counter is what? Counter keeps the number of transactions sent from a account, right? In case of the externally owned. The contract account, the number of contracts which are created by account. So the contract accounts can create the contract, right? How many contracts are created by account? It has to be kept in a loop. It has to be there. A record has to be there. So that counter maintains the number of contracts created by contract account. Balance. Balance will hold how much of ether is accumulated in the account. So that is the denomination is V actually, lowest denomination, which is owned by the account. V is the smallest denomination of the ether, which is equals to 10 raised to 1 ether is equal to 10 raised to 18 V. Such a small denomination it is. Next slide. The code hash. Code hash is a code fragments which are contained in the state database under the corresponding hashes of the hashes for later retrieval. These are the code hashes. why we need to have the hashes? Why there is a code which is already, a code being deployed there. The question arises, why we need to have the hashes for the code? Hashes are required because if you remember in cryptography, hashing algorithms are used to check the integrity of the messages. So here, for everything, whether it is a message, a transaction, or a code, everything, if you want to check the integrity, you need to use certain mechanism. So the best mechanism is to have hash over the code. So even one bit is changed in the code, so that will reflect, drastically in the hash value. So ensure that the code which you are going to deploy there is going to be, the code is not going to be changed, right? So by checking the hash code, this mechanism you know already. So contract accounts code that get hashed and stored as the code hash. So externally owned account, it is a hash empty string because externally owned account doesn't have any code associated. So obviously the hash value will be on the zero string, empty string, not zero string. Yes, right. So for the contract accounts, it is the contract accounts have the contracts which are generated, which are accounted also. How many contracts are there? Each contract has certain code. So that code is hashed to ensure that the integrity of the code is maintained. Then storage root. Storage root, already you know that Merkle root, how you calculate it. It's again hash of the each nodes that comes into the tree on the top, you will get the Merkle root. So it is storage root is 256 hash root node for the Merkle tree that encodes the storage content of the account. Next slide. Yes. The third element is a transaction. A transaction is in Ethereum is a set of instructions. As usual, we have studied transaction in database, transaction in operating system. All these things, they are nothing but set of instructions. But the difference here is each transaction is signed digitally by the accounts. In a sense, I have an account. I want to send certain ether into another account. I need to create that. So whatever the transaction which I am going to submit, that will be automatically signed by the application which I am running, Ethereum application, which I am running. It will automatically create a digital signature over it, so that anybody can verify anytime that who has created this transaction, right? Basically to identify and also check the integrity. Means anytime the transaction should not be changed. So both the things are used here. So initiated by externally owned account, right? Externally owned account creates it and not by the contract account. Transactions broadcasted in the network and they change the state of the EVM. This I have explained it already. The simplest transaction is transferring of ether, but more complicated transactions can be created from one account to another account. Completion of transaction results in creation of new contracts or message calls. So obviously, in the sense when a transaction is completed, it creates a new contract in the system. That contract is stored as one of the contracts in one of the nodes, right? Message also a message call. Miners execute the transaction and propagate the resulting state into the network. This is there. It is there in the Bitcoin also. Next slide. Yes, transaction states include, right? These include counter. The counter keeps tracks of number of transactions sent, recipient address is 20 bytes, right? The transaction should have recipient address to whom to be submitted. Signature, which uses a digital signature algorithm based on elliptical curve digital signature algorithm, which is which uses SECP 256K1 algorithm. Value is the amount of ether to transfer from sender to recipient. The value will be in, normally it will be in B, right? Data is the optional field which to be included in as arbitrary data. Gas price. There are two gas related fields, gas price and gas limit. What is this gas price? I'll explain in the next slide. The amount of V required to execute transaction, right? Maximum amount of the gas can be consumed by the executing this transaction. So these two fields are mentioned there. Please go to the next slide where I can explain gas related things. Yeah, it will be in the next slide. I'll explain it. So two Ethereum blockchains are there. Ether hard fork. Right? Two Ethereum blockchains are there. Ethereum, the classic are also called as unforked original version. It has a certain problem. What is that problem is explained in the next point. The hard forked version is to mitigate DAO attack. There was an attack for the Ethereum blockchain. So that attack is called as DAO attack. Because of that, the new version came, hard forked version, which is a fast going and currently active. Ethereum Classic is used to purchase the gas as a, Ethereum hard fork is used to purchase the gas as a crypto fuel, which is required to perform computation on the platform. Next slide. So the denomination, if you look at V is the lowest denomination. Below that you don't have kilo V, then it's called as Babbage, Mega V, called as lowest, Giga V, Sharon, and we have Zabo, Fini, and Ether. So lastly, it is Ether, which is 10⁻18 V totally. Right? So I have not filled the number of V's there. The expansion last three. It is obvious that it is 10⁻2, 12, 15, and 10⁻18 V's. Right? So lowest one is so many denominations are there. Next slide. Right. So Ethereum virtual machine. Next point what we are discussing is Ethereum virtual machine. Ethereum virtual machine, it's a stack-based execution machine which runs bytecode instructions to transfer system state. Right? We all know that how Java virtual machine works. It's similar to that. This compile code from high-level language to bytecode. Right? You can use compile code and implement there. This executes a smart contract code and broadcast state. So whatever code you write into the smart contract, which will be deployed over the virtual machine and can be executed. The word size of this virtual machine is 256 bit, and it is big endian. It uses KCheck 256 hashing code, elliptical curve cryptography for security related. Stack limit is 1 MB. Works on LiFo. These are the simple things. All of us know it. Please go to the next slide. Ethereum virtual machine supports exception handling. right? It is like, say, for example, there are not enough gas. I think I missed explaining the gas here. So let me explain it one. So gas is basically, brought into picture where when you implement a smart contract, the smart contract code runs. So what was the problem is there was a DO attack. The attack was like, you can run the smart contract for infinite time. So if such smart contracts are implemented and submitted, every node in the network start executing such smart contract. So what will happen? Every node will be running that code for infinite time, right? So it is a kind of an attack on, say, I want to attack Ethereum blockchain. So what I can do is I'll submit a spurious smart contract, and this smart contract, every node is trying to execute, and it goes into infinite loop. So what will happen? The entire resource will be, occupied, and all the nodes will be executing for infinite time. So to avoid that one, Ethereum brought concept of gas and gas limit. In the sense, when I submit a transaction, so I have to give a fee, right? Whoever creates a block, for them I need to pay a fee. That is transaction fee. So this transaction fee will be in terms of gas. So gas is indicating that how much of resource you can use it in the blockchain, right? So it all depends upon how many code, how much of code you are going to execute. So this gas will get decremented every time one instruction is executed. So once the gas becomes zero, the transaction, the smart contract execution will be stopped. Even if it is incomplete, then it is returned back with the exception. So that particular transaction is not accepted, right? So in this way, you can always control the infinite loop of execution of the smart contract. So smart contract, whoever submits a transaction, they have to mention how much maximum you can spend, how much gas maximum you can spend, and what is the fee that you are interested to give. So this is the amount of fee. But if it is not executed, you can go up to a limit of certain gas, right? So I need to buy that gas. Then when I submit my transaction, so as long as that gas limit will be there, transaction will be executed, smart contract will be executed. If it exceeds the gas, then smart contract execution is stopped. If the execution completes before the completion of gas, the transaction is accepted and it is put into the block, right? So that is what the gas idea. So it supports execution handling. If there is no enough gas, there will be a exception, right? Invalid instruction will be sent by the virtual machine. So it returns an execution agent in case of exception occurs. So apart from that, there may be various execution errors that you can see more details there in the Ethereum virtual machine. EVM is an isolated environment. So it is totally isolated, doesn't have access to the outside resource like file system, network devices, nothing, right? It is expected because you cannot have access to that. There is a possibility that there may be a information which is flowed to the Ethereum, and it may just of the thing. So hence, this is more secured and deterministic in execution, right? Ethereum virtual machine execution is very deterministic in the sense for a given input, it has to give a certain defined output only. So Turing complete machine, this is virtual machine is Turing complete machine, but limited by the amount of gas. You cannot run infinite a number of instructions. Required to so denial of service attack is possible if we don't have that gas concept. Next slide, man. Yes. So yes, gas. I explained it already. So it is gas concept came into to hold the problem. The solution is like you can stop the infinite looping and fraud code from execution. So this exactly happened with the Ethereum. That's what DO attacked. Next slide, madam. Right. So gas price is it keeps on changing as the Ethereum value also changes. Gas price also changes. You can also always check the current gas price in the market. It always set before the transaction by the user. Gas limit is maximum amount of gas user willing to spend. So how much I want to spend it if I submit a transaction. So my transaction has to be there in the blockchain block. Then I have to give certain amount of gas, for the ether for the purchasing gas. So gas cost is calculated using the formula. So all blocks have the gas limit. Every block has a gas limit. That is there. It has to be mentioned. Otherwise, it will not be accepted as a transaction itself. Next slide, madam. Yes. So Ethereum ecosystem, you have like EVM operation. This is very similar to what virtual machine we have studied in Java. Like there is a program counter which is pointing to the instruction. The instructions are executed. Bytecode instructions are executed from main memory to the virtual ROM. There are two storage, main memory, and which stores the code during the execution, and memory limited by the gas free limit. So when you set a gas limit, that much of memory allocated for the execution of the transaction. And virtual ROM that stores the program code. More information you can read it, not going in depth of it. But this is the one where you can put a thought and do some kind of research to make it more robust Ethereum blockchain system. Next slide, ma'am. So Ethereum virtual machine now state maintained by EVM, as I told you. This state is updated whenever there is a transaction execution happens. The tuple consists of available gas, program counter, content of the stack, active number of words in the memory. So all these information will be available in the state of the Ethereum virtual machine. Next slide, ma'am. Okay. So now smart contract, the last element in the Ethereum where we will have a discussion. So smart contract, first time it was proposed by Szabo in 1990. Remember that this was not part of the Bitcoin. Bitcoin doesn't have much smart contract. You can write only few codes which is to be written using the scripting language. So this is proposed by Szabo in his paper Formalizing and Securing Relations of Public Network. So that was the idea which he brought in. He defines a smart contract is a computerized program, transaction protocol that executes the terms of the contract. So when you write a contract, that contract it is not exactly a legal contract here, right? What right now I am talking about. This is a code. So the code you have written, you have put in certain amount of logic into the code. So that code has to be executed, which is is a part of transaction protocol. The general objective of the smart contract is to design which are satisfying the common contractual conditions such as payment terms, liens, confidentiality, and even enforcement. Minimize the exception, both the malicious and accidental. The idea is to have minimal, malicious and accidental exceptions. Now, and minimizing the need for trusted intermediaries, right? So basically, not to have any trusted intermediaries in the in between. That's what the idea of the blockchain and Bitcoin is there. Related economic goals include lowering the fraud, loss, arbitration, enforcement costs, and other transaction costs. All these things need to be there. Next slide, madam. Yes. Smart contract, Bitcoin smart contract is very, very limited. No need of trust, no need of trusted third party. Because of it is very limited. Smart contract is a secure, unstoppable computer program. Another author tells that the smart contract is a secure, unstoppable computer program. You cannot stop it in between, right? Representing an agreement that is automatically executed and enforced. What it should have is the characteristics are it should be enforceable, enforcement, right? The smart contract should execute, and what are the logic which are written into it, they are to be enforced. Then they must be secure and unstoppable, right? Secure and unstoppable. It is not stoppable, sorry, it is unstoppable, right? And court of law, which has to be accepted by court of law. The question arises, are they acceptable? We'll see. Are they smart? In the sense we say that they are smart contracts. The question arises, are they really smart? What do you mean by smart here? Then there is a gap between real world and blockchain world. The smart contracts, real world smart contract and blockchain smart contract are orthogonally different. Okay, so that we will see there. And it is expected that they must be deterministic in the nature. In the sense, for any given set of input, it should always give same output for the given environment. We'll see more about smart contracts in the next slide. Next slide, please. See, desirable properties are they must be executed automatically, right? And enforceable means when they executed certain instructions, when they executed, so they must be enforced. Semantically sound. This is which is the first two are minimum requirement, automatically executable and enforceable. The third one is semantically sound in the sense whatever code I write, I should be able to understand it. It should be able to acceptable by the court of the law. Is it there? We will see that. Secure and unstoppable. They must be secure. No time, nobody can modify it, change it, right? And once it is deployed, it should be immutable. And it is unstoppable, right? When it is executed, it's unstoppable. It has to be executed. Next slide, man. We'll see more about this in the next slide. In the year 1990, Ian Gregg proposed a financial cryptography in 7 layers, right? Initial design on the broad, the bond trading and payment system. His idea was to have the bond trading and payment system. Idea is to a document understandable and acceptable by both court of law and computer software. His idea was to that one should be able to write a smart contract which should be acceptable by the court of law and also understandable by computer software. This is very difficult because these two are totally different. Any code which is written in a computer language, the court doesn't accept it because it is a code. It is written in a certain using the Turing language. Whereas if you go to the code and you say that any document you want to, they must be in a legal terms used in the document, and it has to be produced, and so many people have to sign all those things. So there is a legal document which is accepted by court of law and computer cannot understand. And you have here a computer code which is a part of smart contract which computer can read and understand and execute, but court of law is not accepting. So there are two orthogonal properties. So this Ian Greek tried to combine these two, so that any smart contract, if I write it, it should be acceptable by court of law. So that dispute anytime created can be resolved fast. Right? That was the basic idea of the Ian Greek. So what is that desired properties? The contract is offered by an issuer or holder, right? And a valuable right held by the holder and managed by the issuer. That is what the contract is. Readable by human and readable Turing language. Both it should be. Human also could read. Any layman who doesn't know any programming language should be able to read it and understand it and try to resolve the dispute. Right? Both should happen. So, and it should be digitally signed over and top. And has information of keys and servers. It should have also who has created this contract, to whom it was, who are the parties which the part of the smart contract, and a unique identifier for that smart contract. So all these should be there in the smart contract. So that is what he called it as a Recordian contract. So try to do it, and it was very specific to the financial system, right? Next slide, madam. How he did, you will see in the next slide. So this is what the smart contract looks like. If you look the word of law, you have a document from the left. You have a document which is signed by, using pretty good private signature, a written document which has the tag and a lot of code also associated with that. So code is understandable by the computer, and the text part, which is a part of the contract, is written there, is understandable by the law. So both are merged here with certain limitations, and this value will get the digest value, that is hash code value. That becomes the one of the hash code for the next transactions, Merkle root, all those things that you know, right? So this is how the Ricardian contract works using a bow tie model. This was proposed by Ian Greek specifically for the financial cryptography, financial aspect used for the bonds transaction, right? What it was, it can be accepted by word of law, word of cryptography, and word of accountancy also. Then there is an issue. What is that? We'll see in the next slide. Next slide, please. So, yes, issue is like you want to build a smart contract, something like a Bitcoin, which is the simplest one, or Ethereum smart contract, which is more of code, right? And you have Ricardian contracts, which is of more of on not audible. Hello, am I audible, madam? I'm getting messages there that my voice is not reaching. Yeah, thank you. I think some of the participants have the issues there. Okay, thank you, ma'am. Yeah. So these are the two orthogonal things, like two orthogonal things. So Ricardian is more acceptable by the law, right? It is acceptable by the law. Smart contracts which are written with the code are acceptable by the computer. So we need to have something like, which is acceptable both the, law and code. But the problem arises now. How do you create a Turing language which, by using that, you can write a smart contract, deploy it, convert it to bytecode and deploy on the Ethereum virtual machine? So this is a very complicated, because you need to have more semantic approach also. But one solution is like, you can build the domain specific languages, right? Say financial domain specific languages. And, mainly now it is working on a financial aspect because banks are more interested on having blockchain, having their transactions on blockchain. So there are, there are a lot of
Sir, we are unable to hear you now, sir.
Yeah, in fact, I said next slide. I was waiting you to change the slide. Now, am I audible?
Yes,
Yeah,
sir.
okay.
Shall I go on to the next slide, sir?
Yes, madam. Please go to the next slide. In fact, I paused it for 1 minute. Okay, next slide. Yeah. So, idea floated by Clark in the paper for smart contract template, foundation design, landscape, and research direction. So, this is another paper on the smart contract. So, there are a lot of papers coming out for the smart contract. So, smart contract is the one area where all of us can look into and try to build in more smarter contract. But the question arises whether they are smart or not. So what do you mean by smart here? Smart is something which has to do on its own, but that is not what expected from the smart contract. Smart contracts, what we are expecting is it has to run a code which is designed, is implemented by which is being implemented. A certain amount of logic is involved in the code. So it has always has to give a deterministic output. So whatever the given input, it should always give the same output. So basically, smart contracts in the sense and executing on their own or something AI and ML, they are not like that. Smart contracts is more focused on how we can write a smart contract which is understandable by the outside world, the court of law, and at the same time accepted by the computer program. That's what the smartness is. So idea is to build a standard templates that provide a framework to support legal agreements of the financial instruments. So in this paper he has suggested it. So legal process can be linked with a markup language. Suggested design and domain specific languages are possible, are being generated in fact, right? So Solidity and Viper are the two domain specific languages on Ethereum platform. You can explore those two, Solidity and Viper. Next slide. Right, oracles. I think I'm running out of time, so I still have time, madam. Another 10 minutes?
Yes. You can go ahead.
Yeah,
sir.
fine. Then I will complete this oracle. See, oracles are like, so as I explained in the last slide, that Ethereum virtual machine cannot interact with the outside world, whether you take it as a file system or network or devices, IoT devices, it cannot interact. That is what it is expected also. So it has to be deterministic in nature also. Then what happens if I want to supply a real-time data? So how do you get it? So for that there is a concept and there is a system, a component called Oracle, which is part of the blockchain also, which supplies the information from outside world, data source. Like for example, if I can give, assume that I write a smart contract and I have an organization where I want to give dividend to all the stakeholders, all um, the what do you call that? the partners of the organization, they want to we want to give the dividend, and this dividend is dependent on the current stock market value. So I want to provide the dividend on the stock, whichever amount of stock they are holding it. So I write a smart contract that should be executed on say March 30th, on the closing of the date of the financial year, and it should extract information from the stock market. What is the current price of the stock? So depending upon the dividend has to be given. So from where it has to get the information. So that has to come from the Oracle. So Oracle supplies the information, and through a proper and secure channel, it supplies the information to the smart contract. So it can be in terms of push and pull both. The smart contract requires the information, it pulls out from the Oracle. Or the Oracle is designed in such a way that it should push the data, it also pushes the data. So the data can be weather data, world news, data from IoT to the secure channel. Oracle transfer data to the smart contract to secure channel. That's what I told you. Oracles are capable of signing data digitally. In the sense, Oracle also signs the data inside this. So that's how the smart contract can authenticate that it has come from the Oracle itself. So data validation, Oracle can do the data validation and send it so that the proper data goes into the smart contract. Next slide, madam. So smart contracts, we are almost ending here. Smart contracts on Ethereum blockchain are usually part of broader applications such as DOs, right? And crowd-funded project was started in 2016. A set of smart contracts written to provide a platform for investment. This was hacked in 2016, lost almost $15 million. So because of that, it is changed from the hard fork. It was not really hacked, but unintentional behavior that programmer of DO did not foresee that. So because of that, so we could able to come to the hard fork Ethereum. This led to the hard fork Ethereum. So needs formal language for development and verification of smart contracts. So if you are writing smart contracts that really want to be a smart contract, like for example for the healthcare system, so you need to have a domain-specific language where all the healthcare words should be there, which should be accepted by doctors, which should be accepted by the all other entities of the healthcare system. Next slide, please. So what we have now in the conclusion is coming to conclusion here. So Ethereum is an open source, public, blockchain-based distributed computing platform, and it's an operating system featuring smart contracts functionally. Ethereum is most popular permissionless blockchain. Anybody can join it. You know that permissionless and permission blockchain. It supports smart contracts. This is what the advantage of Ethereum is, where Ethereum allows users to create accounts on it. You can create it. You can create smart contracts. You can do experimentation. You can write code. You can write distributed applications, deploy them, do experiments. Create your own private network also, right? So this is not just limited to the cryptocurrency. This is much more than cryptocurrency. Unlike Bitcoin, which is very limited to the cryptocurrency, but Ethereum is much more, where we can write smart contracts. Smart contracts also can contain the logical, the business logic, the logic which is involved as a part of his legal issues also. So it is also open for innovation, right? So this is all about the Ethereum blockchain cryptocurrency. Next slide. So the references are, I have used Ethereum development documentation, which is available open for anybody can download it, check it. And there is one book which I found it very interesting, Imran Bashir Pack. Third edition is available now. You can also refer to that. So this is all about Ethereum. Any questions which are welcome. And before that, I again apologize for the delay which is caused. Extremely sorry for this. I'm sorry, Madam Bhargavi, Madam, and HOD, Madam, for patiently waiting for me, and all the participants patiently waiting for me for this particular session. I hope the talk was good. You people enjoyed it, except that half an hour delay.
Sir, it's okay, sir. No problem.
Okay, thank you, madam.
I hope the participants acquired knowledge on Ethereum. And there are some questions in the chat box. And I'll also allow participants to unmute themselves and ask the queries. So I've given an option for that. So I'll just read out one question that has been posted by Ms. Swaroop Rani. Please elaborate on types of accounts. Didn't understand the difference.
Right.
So your voice is not clear, sir. So your voice is not clear, sir.
Yeah, I elaborated on the accounts when the question was raised, right? So I explained it in the next slide itself when the question was raised.
Okay, sir. Okay.
Yeah, right.
One more question, sir. Elaborate by Ms. Purnima Girish Nayak. Elaborate
Yes.
on data persistence in Ethereum, how transactions are stored.
Yes. Okay. Yes, madam. So, in fact, this is also one of the research area because blockchain has a limited resources, whether it is coming to the computing power on Ethereum virtual machine or on the storage block, right? So we need to write a code in such a way that it takes a minimum amount of memory. So that code consists of the information about the all the data, right, which is being exchanged as a part of the logic in the smart contract. So smart contracts hold all the information. So data persistence will be the part of the blockchain. So then again, there are two issues. Like if I can share that and share it, design issues. What part of the data has to be there in the block, that is on the chain and off the chain. So this is one of the design issue in the application. When you want to design an application, you need to decide it. So this is a part of the data which has to be off chain, and this is a part of the data which has to be on chain. For example, all Ethereum and its values which are stored as a part of the chain only. But any supporting things that can be stored on the off chain. Off chain in the sense a node can have its own memory space where they can store it. Solidity and Viper are the blockchain. They are the part of domain specific languages. I don't remember exactly here. I think they are very specific to the financial sector, because most of the now current trend is to develop the domains, financial domain specific languages. Please, you can, Purnima, you can Google it and find it out.
Okay. Participants, there are no more questions in the chat box. So if the participants need to ask any question, you can unmute yourself and ask. So I think, sir, there are no more questions from participants. So
yeah, okay, madam.
I take this opportunity to thank you, sir, for joining us. Thank you very much for accepting our invitation. The talk shed light on the basics of blockchain, Ethereum blockchain, and for giving insights into the entire Ethereum ecosystem. Thank you so much for sharing your valuable knowledge with the participants, sir. Thank you very much.
Thank you, madam. Thank you very much.
Yes,
Session was good. Questions were good.
Yes, sir. Yes, sir.
Thank you all the participants and organizers.
Thank you very much, sir.
Thank you. Okay.